Okay guys, so today we're going to be looking at how to factor. This should be a review for you. The first thing that you're always going to look for is this greatest common factor. This can happen with any number of terms. You might have 2 terms, 3 terms, 4 terms. You always look for a GCF first. If you have 3 terms, you're going to look for this basic trinomial. This is where you ask yourself, are there numbers that multiply to be C and add or subtract to be B? If the answer is yes, then you should try factoring with the double parentheses. That's what I mean by double parentheses, okay? If we have a general trinomial, this is when we have 3 terms and our A value is something other than 1. See, with this basic trinomial, what's always going to go here and here? X and X. But if we have an A there, then that's going to make things a little bit more complicated. It's not going to be just X and X. It might be 2X and X, 3X and X. It could be anything. The first times the first would have to give us the AX squared. Difference of 2 squares. This is always a great one. If you have 2 terms, you might have A squared minus B squared. That always factors down into A minus B, A plus B. Grouping is this new method that you may not have done before. We're going to use this when we have 4 terms. All right, so we're going to look at this example. We have 2 terms. What am I going to look for? Greatest common factor. Is there anything that 9y squared and 25x squared, x to the 6th can both be divided by? No. What am I going to look for now? Difference of squares. This is the only one if we have 2 terms. Is this the difference, meaning subtraction, and is there a square root of this? What is that square root? Is there a square root of 25x to the 6th? What is it? 5x to the 3rd. Very good. That's because 5x to the 3rd times 5x to the 3rd would be 25x to the 6th. So that's going to have a perfect square root. So because this is the difference of 2 squares, it's just going to go A minus B, A plus B. So it's going to be 3y minus 5x cubed, and it's going to be 3y plus 5x cubed. Now, if I'm not sure I did it right, I could always FOIL it back out. First times the first gives me the 9y squared. Outers gives me 15x cubed y. Inners gives me negative 15x cubed y. What would happen with those outers and inners? They cancel. And so then the last times the last does give me the negative 25x to the 6th. We are correct. When you write your answer, do not write all that. That's just a check to see if it worked. Okay, second one, we have 3 terms. What do we always look for first? GCF. Is there one? What is it? 4x squared, right. So now I have to divide this. What is 8x to the 5th divided by 4x to the 2nd? 2x to the 3rd minus what is 12x cubed divided by 4x squared? Okay, and then what is 20x squared divided by 4x squared? And we are finished. The way that I know I'm finished is because this is an x to the 3rd. That is not in any of our methods. See how if this had been an x squared, I might have to check and see if I could do more with this. But since it's a cubed, we are finished. Number 3, which type is this? 1, 2, 3, 4, 5. 2. This is where I have to set up my double parentheses. The first times the first has to give me x squared. So what has to go in those first spots? The second thing I look at is here. I need numbers that multiply to be 20. Be thinking of that. Tell me some numbers that multiply to be 20. 2 and 10, 5 and 4, 20 and 1. Will any of those add to be 12?
Yes.
Which ones?
10 and 2.
So we have to use 10 and 2. Now, when I do the outers, I get a 2x. When I do the inners, I get a 10x. And I have to get a negative 12x. What will have to be true of both of these to get the negative 12? They both have to be negative. You can go back and check if you want, but we know that the outers and inners work. I should check last times last. Will negative 10 times negative 2 give me positive 20? Yep, so we're right. All right, moving on along. Looking at number 4. This is, we look for a GCF. Is there one? Nope. So I'm going to have to just try setting this up as a general trinomial. First I look here. What times what will give me 2x squared? 2x and x. Now I look here. What numbers will multiply to be 14? 7 and 2, 14 and 1. Those numbers are the only ones that can go here and here. Now, maybe I'm not sure this will even factor. Here's how I can check. 2 times 14 is negative 28. Are there factors of negative 28 that will add or subtract to give me 3? 7 and 4. Right now, yes, it can be factored. I've got to figure out how. What are the only two numbers that can go here? There's 7 and 2, 14 and 1. Where do you want to put the 7? Where do you want to put... Will the 2 go in here? It can't. Like I told you, there will never be the same number in the same parenthesis. In fact, there will never be the same factor. So like this cannot be a 2, 4, 6, 8, 10, 12, etc. So if the 2 can't go here, it must go here. So what has to go here then? 7. I want to check my first times first. They work. I want to check my outers. I get 4x. I want to check my inners. I get 7x. Can I combine those to get a positive 3x? Yes. What would have to happen? Yes. So I have to look, where did my 7x come from? Here, this has to be positive. Here, this has to be negative. One last thing I want to double check, and that's the last. Does the last times the last multiply to give me the negative 14 that it should? And we are correct. All right, here's the new type that you may not have seen before. When I have 4 terms, I have to use grouping. So what I'm going to do is I'm going to group these two, and I'm going to group these two. And I'm going to look for GCFs. Looking at these first two, what is the GCF for just these first two? N squared. If I do 5n cubed divided by n squared, I get 5n minus. If I do 6n squared divided by n squared, I get 6. On the next one. Look guys, I have negative 10n plus 12. What's the GCF for negative 10n plus 12? You have to take this sign as well. Listen guys, this is really important. You also have to take this sign. So we have to take not just a 2, but what? Negative 2. Now, what is negative 10 divided by negative 2? 5n. What is 12 divided by negative 2? All right, now, here's where it gets interesting. I have this term and I have this term. Those are terms. Is there a common factor for those terms? So I can factor out a 5n minus 6. That's what I'm factoring out of each of these two. If I factor a 5n minus 6 out of this term, what am I left with? N squared. Now I look at this term. If I factor a 5n minus 6 out of this term, what am I left with? Negative 2. And then I would check to see if I can factor any further. And I cannot. So I'm finished. Okay? All right, let's look at number 6. What am I going to be using with 4 terms? Grouping. I do 2 and I'm going to do 2. Is there a common factor for these two? 3x squared. What is 6x cubed divided by 3x squared? What's 6 divided by 3? And x cubed divided by x squared? Minus, what's 15x squared divided by 3x squared? -5. Now, is there a GCF for this one? I have to factor out something though. I always have to use this sign. I'm going to put a star there so you remember it has to be this sign that I take out. So I have to take out a plus. And if I have to factor out something, what can I factor out? Yeah. 1. Very nice. So I'm going to factor out a 1. So if I do 2x divided by 1, -5 divided by 1. Do you see how this works now? What is the common factor on this first term? If I take that out of this term, then what am I left with on that? And I take it out of here, and what am I left with? Very good. And that's going to be my final answer. Okay? Do you feel a little bit better about factoring? Some people are like, if you wouldn't have added on the last 2, it would have been fine. But once you do some of these, you will be okay. Where's the first one of those we come to? Number 7. Maybe you should try number 7 right now while it's fresh in your mind and see if you can do it. All right, I'm going to stop there. You have to do through number 12. If you're getting an A in here, you should try the last 3 on your own. I did not post those answers because I want to see who can figure those out.